Okay, so question number 8. How many valence electrons are assigned to oxygen when determining the formal charge of the ionic compound sodium methoxide? Okay, so let's try to draw the structure for sodium methoxide. If we were to count out the total number of valence electrons, sodium has 1, oxygen has 6, carbon has 4, and hydrogen also has 1, but we multiply this by 3 since we have 3 hydrogen atoms in this compound. So now in total we have 14 valence electrons. So now let's try to draw this structure. We know that sodium will have a positive charge since it gave one of its electrons to this compound here, which contains the oxygen. Oops. Just won't draw it in brackets. Bonded to the carbon with 3 hydrogens. And now let's count out how many electrons I've drawn so far. So we have 2 electrons in each bond, and we have a total of 5 bonds. So we have 10. So we need 4 more electrons, and the remaining 4 will go on our oxygen. Okay, so we can kind of draw the ionic bond like this. And we can also find out how we calculate formal charge by using the equation where formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. Okay, so now let's calculate the formal charge of oxygen. And it should be -1. But if we were to calculate it, the valence electrons in oxygen is 6. The number of non-bonding electrons, which are in the form of the lone pairs, is equal to 4. And there are 2 bonds to oxygen. So in total, we have 4 valence electrons divided by 2. So 6 minus 4 minus 2 would give us 0. But if this wasn't in the compound with the sodium, then we would only have two bonds, 2 bonding electrons to the oxygen. So that's why, and we'd also have this extra lone pair as well. And that's why before they come together, this is how it has its negative charge. So let's just show how this -1 is before our ionic bond with sodium. And then after bonding is what we did earlier, which is the 6 minus 4 minus 4 over 2. And then it becomes neutral. So this is after donating electrons to our sodium. Okay, so now let's see what the junior tutor said. Valence electrons are electrons on the outermost shell within an atom. These electrons are responsible for forming a bond with another atom, and oxygen belongs to group 16 in the periodic table, wherein all elements within this group have 6 valence electrons. Thus, when determining formal charge in the ionic compound sodium methoxide, 6 valence electrons are assigned to oxygen. Oh, so they only asked for valence electrons, so I just calculated formal charge just to show how we would do so. So this solution is correct. Okay, so now I believe we are on question number 9.